Hello everyone. Now we are seeing the first question of linear regression. First question is read CSV data into pandas data frame. In the cell we are inputting the required Python libraries such as pandas, NumPy and matplotlib, and we are getting one output. This is the output. First 5 rows. Next second question is find missing values and replace with them in with mean. In real-world data set, some values may missing noisy data, duplicate set. For missing values, we will fill with the mean of the data set. So this is the output. Third question is choose independent uh, choose independent dependent variable. X is dependent, Y is independent. So X we took as alcohol and Y we took as quality. Then fourth question is calculate regression coefficient B0 and B1. They, for calculating linear regression, the formula is to equal to B0 plus B1x. B0 is intercept and B1 is slope. First we are for calculating anything in regression we need x mean and x mean and y mean and numerator, and we are not using any formulas. Here we are using equation, that is this is the b1 numerator, equation for denominator. Next we are finding b no not, that is intercept, b y mean minus b1 into. Then we are printing the slope and intercept. Fifth question is calculate predicted values, that is y predictor. In this we calculate predicted values of all x values. This gives the estimated wine quality. Wine quality means the dataset name predicted by the model. Then sixth question is finding SSE. SSE stands for sum of squared error. It measures the difference between the actual and predicted values. Lower SSE mean better model performance. Then seventh question is RMS. RMS mean root mean square error. It tells us the average prediction error of the model. Smaller RMSE is more accurate predictions. Then eighth question is calculate R square. R square is called a coefficient of determination. It measures how well the regression and model fits the data. R square, if R square the answer is 1, perfect fit. R square is 0, poor fit. According to us, the R square is, according to the data set, our R square is poor fit. Then ninth question, plot the regression line using scatter plot and line plot. Scatter plot shows the actual data points. Line plot shows the regression line. This helps us visually see the relationship between alcohol and wine quality. Then 10th question is predicted y for given x. The x is given as 3, then we use the regression equation to predict wine quality. This shows the regression can be used for future predictions. Next, we are seeing multilinear regression. Multilinear regression uses more than one independent variable. In that first question, read CSV file. Same we are loading the data set and the required dependencies. Next, data cleaning. Data cleaning means missing values are replaced with mean imputation. Then choosing independent and dependent variable. x1 equal to alcohol, x2 sulfates, y is quality. Then we are computing the coefficient with y-intercept. First we are doing mean of variables are calculated. Values are mean centered. Regression coefficients are B0, B1 and B2 are computed. Those coefficients determine how each feature influences the prediction. Then fifth question, we are predicting the y in multilinear regression. Then second question, calculating the SSC. The same formula is used for here also. Then calculating the RMSE. Then calculating then we are predicting the new value. New input values are x equal to x1 equal to 6.5, x2 equal to 4.5, and we are getting predicted y values. Then we are going to logistic regression. In the first question, same we are loading the data set. Then we are data pre-processing. In that pre-processing, we are doing mean imputation that replaces the missing value with the mean, label encoding, converting categorical labels into numerical values. This allows the algorithm to process the data without any errors. Then third question, selecting the feature and target values. X is tends to feature. It contains acidity, sugar, sulfates, alcohol, and density. Dependent value is type in wine category. Then we are calculating the cost or error, cost or error, and reduce the cost or error using gradient descent. This cell defines the logistic regression model. First, we are initializing the weight, then we are calculating the prediction using sigmoid function, then we are computing the cost, update weight using gradient descent, repeat for several iterations. The goal is to minimize the prediction error. Then we are plotting the cost and iterations.